All right, hello. This is section 9.1, and 9.1 is of a right triangle trig. Most of this, again, you should have learned in geometry, but if you're having a little issues, hopefully this video will help you. So here we have a right triangle, and notice that all of this is going to be right triangle trig. If it's not a right triangle, then you're not going to be able to use these methods. Number one says evaluate the 6 trig functions of the angle theta. Okay, so if you notice what you have here is you have 2 of the legs but not the hypotenuse. And so if we're going to evaluate all of the trig functions, we're going to need to know the hypotenuse, and we can do that by using the Pythagorean theorem. So a squared plus b squared equals c squared. And that is going to give you 49 plus 576, which is equal to 625. And the square root of 625 is 25. Okay, so we know the hypotenuse now is 25. So now we want to evaluate the 6 trig functions. So we've got the sine, the cosine, the tangent, and then we've got the cosecant, the secant, and the cotangent. Okay, I find these 3 first, and then I take it and I go find those over there because those are just inverses of ones that you already found. So the sine of theta, the sine, remember, SOHCAHTOA, I write it like this, SOHCAHTOA, okay. The sine of theta is the opposite over the hypotenuse, so that's 24 over 25. The cosine of theta is the adjacent over the hypotenuse, so that's 7 over 25. And the tangent is the opposite side over the adjacent side. So the opposite is 24, the adjacent is 7, the tangent is 24 over 7. Now what's really nice is once you find those, then finding these 3 are easier because they're just the inverses. So the cosecant is the inverse of the sine. So that means that you just find the reciprocal, which is 25 over 24. The secant is the reciprocal of the cosine, so you've got 25 over 7, and the cotangent is the inverse of the tangent, so 7 over 24. Okay, don't think too much on those. SOHCAHTOA, use what you know. Number 2 says, in a right triangle, theta is an acute angle, and the sine of theta is 5 over 6. Evaluate the other 5 trig functions. Okay, so we have a right triangle. We don't have a picture. Always draw a picture, please. We've got a right triangle. We have an acute angle theta. It doesn't matter if you put it here or there, you will get the same answer, okay? But it says the sine of theta is 5 over 6. And the sine of something is always the opposite over the hypotenuse. So we know the opposite side has to be 5, and the and the hypotenuse is 6. Okay, so like we did above, we want to evaluate all 6 trig functions. So we need to know the sine of theta, we need to know the cosine of theta and the tangent of theta. Then we need the cosecant of theta, the secant of theta, and the cotangent of theta. Okay, we were already given the sine, which is 5 over 6. To find the cosine, that means we need to find this leg here. Well, we know that with the Pythagorean theorem that a squared, so we'll say that that's what we're missing, a squared plus b squared is equal to c squared, right? So 6 squared. And then if you solve for that missing value, you'll end up with a squared, sorry, this should have been 5 squared, not 25. I was getting ahead of myself. A squared plus 25 equals 36. And then you would have ended up with a squared being, 36 minus 25 is 11. Okay, so that means that a is the square root of 11. So this right here, that side's the square root of 11. And that's going to kind of change things when we go to talk about what our trig functions are going to look like. And so what that means is that the cosine is going to be the adjacent over the hypotenuse, so the square root of 11 over 6. And the tangent is the opposite over the adjacent, so that's 5 over the square root of 11. However, we can't have radicals in the denominator. And so because of that, when we've got 5 over the square root of 11, to get rid of that radical, we had to multiply the top and the bottom by the square root of 11. And so this simplifies to 5 square root 11 over The square root of 11 times the square root of 11 is just 11. So make sure that you simplify. If you have a radical in the denominator, that's going to be a problem. Okay, so make sure you deal with that. To find these over here, the cosecant is the inverse of the sine, so we just flip-flop that fraction to be 6 over 5. The secant is the opposite of cosine, so that gives you 6 over the square root of 11, but just like down here, we're going to have to multiply both sides by the square root of 11. So that leaves you with 6 root 11 over 11. That's your final answer for the secant. And the cotangent, you could flip-flop that one, but then you would have to rationalize the denominator, so I would just flip the first one that you have. You would end up getting the same answer anyway, so you might as well just take the shortcut while you can. Okay. Number 3 says solve a triangle ABC. So when we solve, what's going to happen is that we want to find all the side lengths, so A, B, and C, and all of the angle measures. So there should be 6 things that we're looking for. We're given some of them, but we're not given all of them. Okay, we know that the side length of B is 13. We know that angle A is 34 degrees and angle C is 90 degrees. And so what I like to do is I like to think, okay, well, what's the easiest thing to find? And in my opinion, the easiest thing to find is this angle B here because you're already given the other 2 angles. So we know that all the angles of a triangle add up to 180. So 180 minus 90 minus 34, that should be 56. So angle B is equal to 56 degrees. So now we just need to find side A and side C. So let's go for side A first. I always pick the 2 things that they gave me. So they gave me the 34 degrees and the 13, and so I have to figure out, well, how could I figure out the opposite if I'm given the adjacent? And those 2 things fit nicely in with the tangent. And so what we can say is we can say, okay, well, we know that the degree is 34, so the tangent of 34 is the opposite, which we'll call A, over the adjacent, which we'll call 13. And then we can solve for our missing value. If we multiply both sides by 13, we can plug into our calculator 13 tangent 34. Just make sure your calculator is in degrees and not radians. Okay, hit that mode button to see that. And then if you do that in your calculator, you will see that A is 8.77. Okay, you just plug it into your calculator straight, just like that, like you see it. Okay. One more. You could really use any values that you wanted to. Again, I like to use the values that they gave me just for rounding purposes. And so in order to find C, I want to compare the hypotenuse to the adjacent. And the hypotenuse and the adjacent, that corresponds to your cosine. So now we're going to take and say, okay, well, the cosine of 34 is the adjacent, which is 13 over C. And in order to find that, remember we learned that trick in class where you could just flip-flop these 2 things. So in your calculator, you want to plug in 13 divided by the cosine of 34. It looks like that. Make sure you finish those parentheses, and you should get 15.68. And those are all of your missing values there. Okay? It's just helpful to make an answer box like this. That way you know you're never going to miss anything, okay? All right, last one. Word problem, but really not that difficult. A parasailer is attached to a boat with a rope of 80 feet. The rope is 80 feet long. Okay, so I like to draw a picture. So here's the boat. A parasailer is attached, and a parasailer is going to go up in the air like this. They're never directly above the boat. Okay, and we know that the rope is 80 feet long. The angle of elevation from the boat to the parasailer, okay, so if this is our water and the boat's right there, the angle of elevation, is 31 degrees. And we want to estimate the height above the boat. So really, the boat's here, but it doesn't really matter if the boat was here or here. The height is going to be the same. Okay, we want the vertical height here. And if you look, you can create a right triangle. So drawing pictures here is very important. Okay, and we want to find the height. So I look at this and I'm saying, all right, self, what am I given? And I'm given the opposite and the hypotenuse. And so I have to think, okay, what trig function can I use with the opposite and the hypotenuse? And that's the sine. And so if we take the sine of 31 and it's equal to the opposite, which is our height, over the hypotenuse, which is 80. If we multiply both sides by 80, then we can find our height. So 80 times the sine of 31, and that's equal to 41.2 feet. So the parasailer is 41.2 feet off the water, which should about make sense. I know a lot of you don't go parasailing in your free time here in the great state of Missouri, but if you do, that would probably make sense. Okay. Hopefully that helps. If you still need some more assistance, please come see me. I'll be glad to help.